Woohoo, we are live. This is Math 60 Intermediate Algebra. We're in section 3.6, and this is part 3 because it's problem number 3, because word problems take a long time to do. Woohoo! So I've got my support Godzilla, I've got my calculator, lots of colors. Let's do this. The nice thing about this problem, a chemical stockroom has a 20% alcohol solution. It sounds just like the previous one. So the setup is going to be very, very similar. So let's get down to it. A chemical stockroom is 20% alcohol solution and a 50% solution. How many deciliters of each should be used to obtain 90 deciliters of a 30% solution? So again, let's talk. If this is, oh my goodness, I don't even know what this is. If this is a very strange looking 2-liter soda, half of this would be 1 liter, and then one tenth of a liter is a deciliter. And it's written little d, capital L. And again, most of the time, the people who are going to run into these sorts of measurements are going to be either in the medical fields or in sciences. But it is possible for regular people to come across these. And certainly if you do your own home brews, if you do your own photography at home, you have to mix chemicals. So these are not so ridiculous. But granted, these are unusual problems. Hopefully it is clear that this is a mixture problem, literally because you're taking two different things and mixing them together. And let's look at the things we're looking at. This is a 20% alcohol solution, so very dilute. So 20% is 1/5. And again, I'm going to assume that all of our solutions are in water, so aqueous solutions. So we've got the 20% solution, and we're going to mix it with a much stronger solution. This is going to be a 50% solution. And we're going to end up coloring is so relaxing. We're going to end up with a much larger beaker, and we want 90 deciliters of a 30% solution. So more than a fifth, almost a third. And again, if you wanted to do these problems a different way, you could always try doing them in terms of, rather than looking at the alcohol quantities percentages, you could be looking at the water percentages and do the flip side of the problem. So again, if we're going to look here, if I have a 20% solution and a 50% solution, halfway, and you guys know how, hopefully you know how to find half of something. The halfway mark is if you add them together, 20 plus 50 is 70. 70 divided by 2 is 35. So 35% would be halfway between them. So since we're looking for 30%, which will be close to there, what we're expecting is that we're going to have a lot more of the 20% and a lot less of the 50%. So let's take a look. I'm going to make a chart. Again, I will keep saying it on every single problem. You don't have to make a chart. In fact, fun fact, I had never used a chart or any of these techniques until I came to teach at City College. Before that, I had been at other schools and we used other techniques. So a lot of times the book that you use will help steer you towards certain techniques. I do like this technique now that I've gotten used to it, but I did have to learn it when I started teaching here. Okay, I'm going to take a 20% solution plus a 50% solution and end up with a 30% solution. I don't know if you guys remember, but the first quantity we're going to look at is the total amount. So now we don't know how much of the 20, we don't know how much of the 50, but we do know that it's going to be 90 deciliters of the 30%. And again, I need two variables. You can call them anything you like. I'm going to use X and Y because I'm guessing that most people would say that in class. Then we've got strength. How much alcohol is there? 20% becomes 0.20. 50% becomes 0.50. 30% becomes 0.30. And then here I'm going to do total amount of alcohol, just like we did before. And here, to get to the total amount of alcohol, remember, we're multiplying. So this is going to be X times 0.20 or 0.2X. This is going to be Y times 0.50, and that's 0.5Y. And then this is going to be 90 times 0.30, which happens to be now 3 times 9 is 27, so I can do this one in my head. 27 deciliters. Okay, so if we look at the problem we did in the chapter, in the second problem that we did right ahead, you can compare and contrast these two. The setup, identical. The strength, almost identical. Remember, we had distilled water, which made this zero out. Now this is not distilled water, so none of these become zero. So we're going to deal with all of them. That's okay. We can totally do that. I'm going to, since I already used orange, this is going to be my pink equation. Remember, the first column will give us the pink equation, and the last column will give us the green equation for this problem. You can color them whatever you like. But basically, the first column and the last column will give us equations we can work with. Remember that strength is not something you can add. You can't say 0.2 plus 0.5 is 0.3. And I know that it looks like you should be able to say 0.5 minus 0.2 is 0.3, but that's just a coincidence. Generally speaking, these numbers don't interact in that way. Okay, let us write out the equations. So the pink equation coming down the chart is X plus Y equals 90. That's the pink equation. And the green equation, 0.2x plus 0.5y equals 27. That's green. Okay, now I'm ready. I'm going to go ahead and see if I can come up with a way to use. Now here you've got a couple choices. Since you've got an X and Y, you can use substitution. I generally don't use substitution. I really like elimination. So that's the way I'm going to go about it. Feel free to pause the video right now, solve the equation however you'd like, elimination or substitution, and then turn it back on and see if we get the same answer. For elimination, I'm going to multiply by 10 on the bottom, just because I don't want to have to deal with decimals. So I got 2x plus 5y equals 270. Now up top, I need to multiply by something so that I can cancel. So either I'm going to cancel the x's with the -2 or the y's with the -5. I think I'm going to go with the -2. So I multiplied the whole top equation by -2, the whole bottom equation by 10. Now I'm going to add and smear. The x's cancel. The y's end up with 3y. And this -180 plus 270 is 90. Divide both sides by 3. Y equals, Woohoo, 30, yay, yay. But we're not done yet because that's just why I need to find x. X plus y is 90, y is 30. I'm getting so excited. I don't know if you guys are. This problem is almost done, yay. So x equals 60, and again, what are the units for this? We can double check. Deciliters. This is all in deciliters. So this is 60 deciliters, and y is 30 deciliters. And the question becomes, did it match our prediction? So our prediction was 30% is closer to 20%. So x should be bigger and y should be smaller. X, in fact, is twice as big as y. So that worked. Woohoo! That was awesome. Okay, so then what? Well, now what we can do is we actually can go ahead and do another problem. I know this is bonkers, right? Let me get my pens all set up. Okay, are you guys ready? So what I'm going to recommend for this problem is it's very similar. It's going to look really different, but it's actually really similar to the problem we just did. And so I really want to encourage you, when I pull this sheet away and you can see number 4, please try it on your own. Try it before I say anything. See if you can get through it. Okay, so there we go. Here's the problem. A gourmet food store manager wishes to blend coffee that sells for $7 per kilogram with coffee that sells for $9.50 per kilogram to produce a blend that will sell for $8 per kilogram. Do you see how that's? So instead of percentage alcohol, we're using the price per kilogram, or the cost per kilogram. How much of each should be used to obtain 100 kilograms of the new blend? So pause the video and try it on your own. I'm holding very still. Have you paused? Okay, pause the video. Okay, pause it. Okay, good. Okay, so now, are you back? Woohoo, did you solve it? Woohoo, let's see if you and I get the same answer. Okay, so the word blend, the fact that they're bringing different coffee together, this is what tells us this is a mixture problem. In this case, I've got coffee. Let's see, I should do like a bag. Oh my goodness, how do I do a bag? That's kind of a bag with coffee. Okay, so coffee for $7 per kilogram. And we want to, well, it looks kind of like a stocking. Okay, well, maybe not go into art. $7 per kilogram with one that sells for $9.50 per kilogram. And we're going to end up with a bag of coffee that's a blend for $8 per kilogram. So does this even make sense? Well, if I'm going to take something that costs $7 per kilogram and something that costs $9.50 per kilogram, what would be halfway in the middle? So if we add them together, 7 plus 950 is 1650 divided by 2 is 825 is the middle. $8 is just a little shy of the middle. So $8 is going to be a little bit more of the $7, a little less of the $9.50, but we could totally do it. It sits in the middle of those two. So shall we set it up? Now, in a lot of ways, this will be identical, and in a couple ways, this will be really different. This is not alcohol. This is coffee. So I've got the $7 per kilogram, the $9.50 per kilogram, and the $8 per kilogram. So those are the prices, or those are the blends, however you want to think about it. This last one you could also call the mix, like we have in the past, I've pointed out. The first column is still the total amount. That will always stay the total amount. Now, what have we been told? In this problem, we look, if I look and look and look, I see 100 kilograms. What is 100 kilograms? And it says obtain 100 kilograms of the new blend. So that's the total down here. That goes down here. So I'm going to write in 100 kilograms. And I'm glad because the kilograms match. Now, if this had been grams and this has been kilograms, then we would have had to work really hard to make them match. But they already match. We're good. We don't know how much of these two. So again, just to keep it consistent, I'll do X and Y. Feel free to do other letters, whatever variables you like. Now, normally in the middle, we would do the strength. I'm not going to do the strength. I'm going to do the price per kilogram. So this is $7 per kilogram. This is $9.50 per kilogram. And this is $8 per kilogram. Now, remember in the past, I've said, as we move across, these are all going to share this tendency that we're going to multiply. If we take how much we have times the price per kilogram, what will we end up with? Well, if we take the number of kilograms times dollars per kilogram, the kilograms cancel out and we end up with the total cost. So slightly different, but the multiplication is the same. The basic setup is the same. Woohoo? Woohoo. Okay, so let's multiply x times 7. I'm going to write 7x. Y times 950 is 9.5y. And 100 times 8 is 800. Hopefully at this point you're starting to feel like, oh, okay, we're doing the same thing over and over and over and over again. And the answer is yes. And we call it math. Woohoo! Okay, so let's see. I'm going to take this. Oh, that will conflict. Let me use green here. I'm going to use green for the first one. First column. I know I used green in another place before. That's going to be green, and this will be the yellow. And as before, the middle column does not become an equation. The two columns that have variables in them do. So first column, x plus y equals 100. Last column, 7x plus 9.5y equals 800. Here's the green one. Here's the yellow one. So far, so good? Okay, let's see what we can do about solving this. Woohoo. So I'm going to give you a moment to think about this, or you can always pause it. You can always pause these videos. So I want to cancel x's or y's. I've got an x plus y up top. I've got 7x and a 9.5y. I'm going to go ahead and use a -7. I'm not going to use anything in the bottom equation, just going to leave it as is. Multiplying across, I get -7x minus 7y equals -700. And when I add, x's cancel out. I end up with 2.5y equals 100. Okay, 2.5y over 2.5 equals 100 over 2.5. Y equals, you got it, 40. And again, I look back at the original problem. Where did I put the original problem? I ate it. Did I really eat it? No, there it is. the original problem, and I remind myself that y and x are being measured in kilograms. And then I say, okay, I need to find x. I've got x plus y equals 100. So x plus 40 equals 100. X equals 60. So x is 60 kilograms. Y is 40 kilograms. Does it match our prediction? Our prediction was 8 is closer to 7, so it should have matched. There should be more x, less y. More x, less y. You guys did it. You guys are brilliant and smart and wonderful. And we are now halfway done with the problems in this section. Woohoo! Next video, more word problems. Yay! Dance time. Dancey, dancey, dancey. Dance, 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 dance.